Okay, guys, we're starting Chapter 8. Chapter 8 is about applications of definite integrals, which you know what applications usually means. It usually means word problems. So, 8.1 is about accumulation and net change. First, I want to go back to something that we learned before, which was displacement. I'm going to write this down. Displacement. So, if you remember, displacement is the net change from where maybe a particle or object, we could say from where an object, we'll say. From where an object started to where it ended up. Okay, that is the definition of displacement. All right, so if I was going to find the integral of the rate of change, wouldn't that make sense that that would be the net change or the displacement? Okay. All right, so I'm going to read this word problem. We're going to do this one. Mr. Brust is driving across town to Mr. Sullivan's house to play with a new set of Star Wars figures. Mr. Brust's speed would obviously vary throughout the drive, but because he is so cool, he came up with a function that represents his velocity in miles per minute at any given time, t in minutes, since he left his house during the 30-minute drive. Set up the expressions for the following scenarios. Use a calculator to solve. So here, right here, v of t, this is the function that he came up with to represent his where he is at any given moment on his drive. Okay, so first of all, how far is Mr. Brust from his house after 10 minutes? All right, that is a question. So look at this graph right here is set up in increments of 5. First of all, I should tell you. So this is 5 minutes. This is 10 minutes, 15, 20, 25, and 30 minutes, okay? All right, so if we're going to look at this, if you think about this, if this is the velocity function, it would make sense, wouldn't it, that the derivative, the integral of that velocity function, v of t, dt, would give me my net change and how far you've traveled, okay? So your displacement, which is what we're looking for because we want to know how far from his house is he from his house after 10 minutes. All right, so this is actually going to be going from 0 to 10 minutes, okay? So this is a definite integral. All right, so we could kind of integrate this function. Now, if we did I'm going to kind of do this quickly so it's not a long video, but basically, if we did u substitution with this first one, sine of 0.3t, we would come up with the integral of that as being negative 1 over 0.3 cosine of t. Okay, and if we did the integral of the natural log of t plus 1, well, it would be plus 1 over t plus 1. And then the integral of negative 2 is negative 2t. Okay, all right, so if we did that from 0 to 10, I'm just going to kind of jump ahead a little bit, but it would come out to be about 3.01 miles. So this is what this is saying. In the first 10 minutes, Mr. Brust has traveled 3.01 miles from, he is 3.01 miles from his house, okay? Now, here's the thing. This is how you're going to interpret these graphs. You see this part of the graph right there? That part of the graph means that he is traveling away from Mr. Sullivan's house. All right, so here's the deal. Here's the starting point, and here's the ending point. That represents the 30 minutes that he's driving, okay? And he starts over here. He's starting at at his house, and then he is moving away. So here's the thing. see how this is below right here? This is below the x-axis. That means that he is driving away from Mr. Sullivan's house. So maybe in those first, it looks like about 2.5 minutes, maybe he went and got gas, okay? So he must have been, he had, or maybe he had to go drop something off, whatever case he was out, it was out of the way. He kind of went away from Mr. Sullivan's house, okay? Once he got to this point right here, now he's above the x-axis, and if you look from here to here, he is driving, getting closer. He's getting closer to Mr. Sullivan's house, okay? So the question was, the second part of the question was, is he going away from his house or towards his house at that moment? He is going towards. So at that moment right there at 10 minutes, he is going towards Mr. Sullivan's house. Okay, so above the x-axis represents you're going forward. The below the x-axis is that you're going backwards, which, you guys do remember that from earlier on in the year. Okay, part B. How far is Mr. Bruss from his house after 15 minutes? All right, so it's going to be that same function, but now it's going from 0 to 15 of v of t. And again, to save time, I will tell you that if you plugged all this into your calculator and figured it out, it would be that he was 3.397 miles. He has gone so far away from his house, from the starting point, okay? And the question you might ask is, well, why is it not much further? In 5 minutes, he's only gotten, only 0.3 miles further. And the reason is because if you look at the graph again, okay? If you look at the graph again, well, at this point here, he's, going, like, it looks like from, like, maybe 12 or 13 minutes to 15 minutes, he's going out of his way again because he's below the x-axis. So it's kind of like, again, displacement is kind of like the net change. All right, part C. Well, I guess I should answer this. Is he going away from his house, or he's going away from... So is he going away from his house, or he's going away from Mr. Sullivan's? So he's going away from Mr. S's house. Okay, if Mr. Bruss arrives at Mr. Sullivan's house after 30 minutes, how far away does he live? Okay, so here it is, from 0 to 30 minutes of v of t. That comes out to be 22.824 miles. All right, so this is going to be how far apart they live, all right? If Mr. Bruss arrives at Mr. Sullivan's house after 30 minutes, how far away does he live? Okay, this one's a little trickier, part D. Okay, how many miles did Mr. Bruss drive? So in this first one here, okay, part C, that is just basically asking how many miles did he travel in those 30 minutes, and the answer there was, or I'm sorry, not how many miles, but this was how far away do they live. Okay, so that again is displacement. So going from Mr. Bruss' house to Mr. Sullivan's house, it's 22.824 miles. However, in part D, it's trickier because now they're saying how many miles did he drive? Well, he clearly drove out of the way because there's, a couple moments in time here. I can highlight them right here and right here. Those parts of the trip, he was below the x-axis, and therefore he was driving out of the way, which means he probably drove a little bit more than 22 miles total. So here's what you're going to do in a situation like this. You would do 0 to 30 of v of t. However, you would do the absolute value of that dt. I forgot the dt up here, okay? If you do that out, okay, and you actually there's different ways you can do this on your calculator, you would end up getting 28.497 miles. So again, like I said, it's a little bit further because he did drive out of the way a little bit, okay? All right, now let's kind of talk about the next thing here. Okay, what I want to fill in the blanks here is that velocity, and if you guys remember, what's velocity? Velocity is the first derivative. So think about it. What is the integral of the derivative? Well, it's the displacement or net change, okay? And if I asked you to find, like how we did just here, the the integral of the absolute value of velocity. Well, that's a little different because that's going to equal the total distance traveled, just like we saw in the previous example. Okay, don't get that confused with the absolute value of velocity as speed. I don't know if you remember that, but we were doing those graphs in this first semester, okay? Here is an example here. We got a particle's velocity is given at v of t is equal to t to the third minus 2t squared plus 1. If x of t represents the position of the particle along the x-axis, find the following. The position of the particle after 3 seconds if x of 0 is equal to 5. Well, think about that. That means that at 0, the particle has already moved 5 units, okay? So you want to take that 5 and you want to add it to going from 0 to 3 of the function. And the function is t to the third minus 2t squared plus 1, right? dt. All right, so if I wanted to integrate this, well, it's going to come out to be, well, with that 5 just stays the same, but then when I find that integral, it's going to be t to the, bump it up 1 to the fourth divided by 4 minus 2 t to the third over 3 plus t. The integral of just of 1 is t, okay? And we're doing this, okay? Now, that's only this part of it is going from 0 to 3, okay? So I guess I'm going to try to do this quickly to kind of get through this, but if you added this out, 5, it would be 5 plus, I'm going to plug in the 3 here. I would get 3 to the fourth, which is 81 over 4 minus 2 times 3 to the third, so 2 times 27 is 54 over 3 and plus 3. All right, when I add all that up just to save myself some time, okay, I get 41 over 4. 5 plus that whole thing, I get 41 over 4, okay? And now I have to take that whole thing now and subtract it from, okay? I have to subtract it from 0 over 4 minus 0 over 3 plus 0, which really, because I'm plugging in that 0 there, it's just going to be 0. So this is going to be my answer, okay? All right, moving on. The position of the particle, they want to know what that position of that particle is after 2 seconds. If at x of 1 is equal to negative 2, well, here's the deal. It's going to be negative 2, because that was the position you're at, plus, and it's after 2 seconds. So it's going to be from, because we already know that x of 1 is at negative 2, it's going to go from 1 to 2, okay? Of that same function, which is v of t dt. So it's this same function here. So we already integrated it. So it's going to be this. It's going to equal negative 2 plus this whole thing, t to the third, t to the fourth over 4. Let me erase that. Minus 2 t to the third over 3 plus t. All of that going from 0 to, from 1 to 2. Okay. All right, and so when I do that whole thing out, I am going to just to save us a little bit of time. It's going to be negative 2. I should put this in parentheses. Negative 2 is going to be 2 to the fourth, which is 16 over 4, which is just 4 minus 2 times 8. So 16 over 3 plus 2. All of this, hold on, this should be a plus, not a minus, equals. Okay, all of this minus, oh, look, check it out. These two cancel out. Minus, and now I'm going to plug in the 1. So it's 1 to the fourth over 4 minus 2 over 3 plus 1. Okay, well, whatever. When we do all of this out, just to kind of make things quicker here, it comes out that my final answer ends up being negative 23 over 12. Okay? All right. I think I'm going to stop right there. Maybe what we will do is talk about this in class. Or, you know what? Actually, yeah, we'll talk about this in class because we only have a little bit more and I want to stop the video. All right, guys, try doing some of the homework, please, and I will talk to you in class on Tuesday. Bye.